Good morning, students. Welcome to online lecture series of discrete mathematics. So, last lecture we have studied these groups. So, what is the semi-group, group, and monoid? So, what is this semi-group? Semi-group satisfy the two property, that is associative, and first one is a closure property. Okay? For the monoid, it is associative, closure, and identity element. Right? You have to satisfy these three properties for the monoid. And for a group, you have to satisfy this associative, closure property, identity. Right? So you have to find out the identity element. Then, and last one, you have to find out the inverse element for the every element. So this is nothing but your group. So next is abelian group. So what is this abelian group? The system G comma star is said to be an abelian group if first one it is a group and second one it is commutative. So we know the group. So to satisfy the group, you have to satisfy the four properties. First one is a closure. Right? Second one is associative. Next is identity element, and fourth, that is a inverse element. So here one additional property here we have to satisfy for this abelian group, that is commutative property. So consider the example. So consider a system G comma star where set of all the non-zero real numbers and star is a binary operation defined by A star B is equal to AB by 4. So here give one definition, that is A star B is equal to AB by 4. So here we have to show that this G comma star is an abelian group. So for this abelian group, we have to prove this is a group and it satisfies also a commutative property. So here we have to satisfy one by one property. So closure property. Since this A star B is equal to AB by 4 is a real number, right? So this is belongs to your G. So this, right? So closure property is what is whatever your operation is, A star B is equal to AB by 4. So this AB by 4 is also a real number which belongs to your this this whatever set we consider that is real number, right? Belongs to that real number. So second one is associative. So for associative, A star B star C is equal to. So whatever a definition is given in our question, that is A star B, that is defined, that is AB by 4. So here A star B star C, right? So for this, A star B, right? So as per our definition, this A star B is equal to AB by 4. So for this A star B, so we can write like this AB by 4. Right? AB by 4 star C. So here again, next, consider this is the A, right? Consider this whole bracket as a one element, and this is your second element. As per our definition, right? The second number. So as per our definition, when there is a star operation between the two elements, two numbers, it's A star B, right? So we can write like this AB by 4. So for this is a first and this one is your second. So we can write like this A C. So what is this A? A C nothing but the AB by 4. So AB by 4, right? This is the first, that is A B by 4, right? to C divided by 4. So that is equal to A, B, C divided by 60. So we will get this A, B, C divided by 60. Second, your RHS, that is A star B, B star C. So here again B star C as per our definition, right? So we can write like this for B star C, BC by 4. So A star BC by 4. So right. So this is your first number. This one is your second. So first and second number. So as per whatever define A star B is equal to AB by 4. Same here we define ABC divided by 60. So here LHS is equal to RHS. So this star is a associative operation. Star is a associative operation. So next, identity. So next we have to do here identity. So to find the identity element, so assume this is a positive real number. E is positive. So E star A is equal to A. So if this is a, assume that this E star A is equal to A, where A is belongs to this G, right? So as per our definition, means a star operation between the two numbers or elements, right? So we can write like this EA divided by 4. Right? So consider this E is your, assume that E is your identity element. So here we have to find out whether this is correct or wrong. So EA by 4 is equal to A, right? So or can say A gets cancelled. So E is equal to 4. So here we will get, here we get a one identity element, that is a 4. So here 4 is your identity element. So here A star E is equal to A. So same here A by 4, that is A, is E equal to 4, right? So thus identity element is a 4. For inverse element, let us assume that A belongs to G. If A inverse belongs to this real number is inverse of A, then A star A inverse is equal to E, right? So whenever we assume that A is elements that belongs to this group G, then inverse of A, that is A inverse, right? So whenever there is a star operation between this A and A inverse, right, is equal to a identity element, right? So A inverse, A in A star A inverse is equal to identity element. Whatever that is your identity, what is our identity element? That is a 4. So A inverse, right, is equal to 4. So as per our definition, right? So we can write like this: A inverse divided by 4, that is equal to 4. So A inverse is equal to 16 by A. So here we get the inverse of A. So what is the inverse of A? That is 16 by A. So thus we can say that inverse of A in a G is a 16 by A. So this also satisfies the inverse element is present. Then last, commutative. So the operation star is a commutative since A star B is equal to AB by 4, right? So commutative means what? A star B is equal to, right? We know what is a commutative. Commutative is nothing but the A star B is equal to B star A, right? So as per our definition, what is A star B? AB by 4. What is a B star A? Same, BA by 4. So here both are equal. So we can say that the system G comma star is a abelian group. Okay, so we stop here.